everybody, welcome to the channel. So here is my IPG 1500. The skin is the legacy unit, but inside nothing is legacy anymore. I told you guys this once again, and once already. And this is brand new China welder, I special ordered. It arrived around November, mid-November, but the very latest. What you guys saw on the previous video, if you didn't, then check it out. When I make a tear down, I mean not literally tear down, I didn't take it apart, just opened the doors and showed all the inside. And I said, basically, almost anybody could build one if you have access to the components what necessary to do it, and you know how to handle the firmware. It's not that hard, especially if you have a very good computer skills and stuff like that. You can read, so you can connect the wiring. Now the other fact I wanted to say, basically all the China laser industry is operating. There was one gentleman, I think it was from Hero Laser, he was visiting in China factory where they're manufacturing the bodies, basically the whole structure for the laser cutters. Okay, he's 100% right. He explained everything the way it is. But what he did not explain, since China is so big, 1 billion plus people, right? I think the very last survey was 1.4 billion or something like that. They have regions, and each region has a couple of companies. I don't know why we call it manufacturers. They don't literally manufacture this. They buy the casing, they buy the components, and they assemble it. I call them assemblers. So same thing with the laser cutter. And today I'm going to show you the laser cutter. Also a custom order. So this is not coming from some company and let's make it call or whatever, it doesn't matter. We name it any name. So I have a bunch of contacts in China, know people they doing this, know people they doing that, even milling machines. We could talk about the milling machine in another video if you guys are interested, but you guys have to leave in a comment because I have a 16 feet long milling machine over there and a conventional 52 by 102 envelope milling machine as well. So I already opened the door on laser. The reason I'm doing this, so you see how much more simpler to make something like this than that one. Now the gentleman brought up the company Boshu. Basically it's kind of equal to Ruifa, but in different domain. It's a laser cutting domain. This is the laser welding domain. The basic architecture is pretty much the same. You have the lasers, you have the power to the laser, you have the control board, but over there you have to have a CNC. Now, the way they make it, one single board controls the CNC and the laser at the same time, and I will show you. And it's much more difficult, much more complicated. I mean, it's not like, you could build that one too. A lot of people, they do it maybe a little bit smaller scale, but they do that. Now, I want to show you something. I already put this over here, but it's not glued because I'm removing, it was a sticker over here, all in one. And basically, I cut a new plate, and this plate is just as good, as perfect as my drawing was. What I miss, basically, the lettering is so little, it requires 0.2 millimeter or less when I export the file. I mean import, sorry. And my software is set to 0.3 millimeter. So there, I lost some finesse in the lettering. So I'm going to recut it. All I'm going to do is just change the import file size. Anything less than 0.1 millimeter can be trashed out, the rest of them not. And we ended up with, I'm going to show you in a second or a minute, whatever, the fine details on this humongous big machine. Because what I want to talk about is how trash the Chinese equipment is. Okay, this is one of the example how big trash the Chinese unit. And I'm going to put this in this background, remove my camera. I try to zoom in as much as I can. Look at this. Now look at those lines in the 3D design. See those lines? I'm gonna grab the caliper and we're gonna check it out. Zero heads. Okay, I sanded it because I couldn't remove the plastic. I'll show you the plastic. I'm gonna walk over there. We come back over here. See, I cut it out of this and the plastic burned into it so badly I couldn't remove it, so I had to grind it up. Now we're gonna drop the caliper. It's already set up over here. Okay, so zeroed out. Let me shift it into millimeters. Let's check one of these tiny lights over here. See? A little bit less than half a millimeter. Okay? And look, how perfect. Look at it. Okay, it's a no-name Chinese. You got a little shadow, probably me. And try to find a better. So look at the details. So in the lettering, the S, that's an import failure, because if you can do such a precise detail, then obviously can do a millimeter detail, right? So I know in fact that was in the import. Same thing over here, import file problem. So all I have to change is go down to 0.1 millimeter. That's it. So see this? Okay, let's check something else. Let's say this carats over here. Okay, less than 1 millimeter. So over here, these lines are less than 1 millimeter. The diameter, it's 2 millimeter. Okay. Let's try to check if I can grab into the lettering. I'm not sure I will be able to. Maybe over here in the end. Yes, I was able to. See, half a millimeter, just a little bit more than half a millimeter wide is the lettering. Okay. Now some say sticker don't mean legally anything, or what the fuck you said, doesn't matter. Okay, let's look at this guy over here. So that's the interior. So this is the board I was talking about. This one handles the communication between the laser and the CNC itself. So it's 2-in-1, okay? And the gentleman was mentioning Bochu, or Boshu, I don't know how to pronounce it perfectly, but doesn't matter. I am not sure which company made this, but I have a hunch maybe it is, because it says BCL, and that kind of gave me a hunch. See, I have servos. See, servos. It's so fast, I had to reduce the speed to 30%, the fast travel speed. In CNC language, they call it rapids. I had to reduce the rapids to 30% because the machine jumped off from the table. I mean, not table, these little legs, those tiny little leveling legs here. See? So there's no way to connect the machine to the leg unless I welded or figure out something, and therefore the inertia and the whole setup, and When I purchased it, it's like 7, 8 years, I don't remember, something like that. It was not the top of the line. I was looking for something I can afford and I can make them build to me, right? And the guy named Jimmy, now he's operating out of Thailand. He and his crew made this machine for me. And obviously they purchased the casing from pretty much the same place the hero guy walked on his video. Or if not, then another region, but I kind of have a hunch this is from the same factory, because they look pretty much the same way. Each region has tiny little bit of differences within the design. Not much, just a little bit. But it doesn't matter. Excellent body, excellent. This machine served me very well, and I paid less for the machine than the delivery was itself. So the shipping was more expensive than the machine itself. We're gonna go back to the laser, because now we're gonna play with the welder a little bit. Oh no, let's go back a little bit more. Also, this is coming from the same machine. That was a piece of anodized aluminum, all right? And I just made engraves. I personally know these people. I'm fishing with them, so I like to fish. That's why you see a lot of fish. The Cobra design is visible on one of my other machine. So look at that. Every single unit can engrave. Okay? So what they're gonna say, even the factory say, don't do that because the reflections, and they 100% right. But when you engrave, you use a lower energy settings. That's one thing. The second thing, you use an extreme high speed as much as you can handle, and still the final product, what you can see over there, it comes out perfectly. So, and the head placement has to be far off from your port. I saved the settings, and there we are. Okay. So the same Chinese unit. I'm gonna put this back. I don't know if it's gonna stick. It's still sticking. So I'm gonna cut a new one, make sure all the lettering. I'm not gonna worry about the D's and the O's and stuff like that, maybe, but I don't think I care. And every single area has different colors, going to have different colors, and I'm gonna light it up. Okay, that's the idea. Maybe in the weekend I will be able to make it, I hope. Now we're gonna go back welding after this discussion. Oh no, before we welding, we're gonna do something else. Let me lower this.
In this test, I wanted to compare the real destructive power of my 2 kilowatt, 20 micron laser source against a typical 6 kilowatt unit running a 100 micron core. And the results show something most people never think about. Power means nothing without density. I started by hitting polished concrete at point-blank range using the dual circle pattern. The beam drilled a clean 3mm hole, about 3 millimeters deep. That's not surface discoloration. That's actual penetration from concentrated energy. Then I repeated the test from 32 inches away. With the beam fully diverged, it didn't punch a hole anymore. Instead, it blew the polished surface off in the exact footprint of the expanded beam. Same energy, larger spot, lower density, different failure mode. And here's the important part. A 6 kilowatt, 100 micron unit cannot punch a 10 millimeter hole into concrete from 32 to 36 inches away. The beam is simply too large and the power is too spread out. The wattage number is bigger, but the energy density is not. When you do the math, my 2 kilowatt source at 20 microns ends up 8.3 times more power dense at the workpiece than that 6 kilowatt, 100 micron beam. That's why my unit can physically damage concrete in ways the higher wattage machine can't replicate at distance. On steel, the same beam won't punch holes. Steel is ductile. It melts and forms a weld pool instead of shattering. Concrete is brittle. It cracks and ejects material. Same laser, different material, different physics. So the takeaway is simple. A well-focused, high-quality beam can outperform a higher wattage unit with poor beam parameters. Power density wins every time. And here's the part that makes this comparison even stronger. We don't actually know the real beam size of that 6 kilowatt unit. It might be 100 microns, or it might be 150 microns. And to be clear, those numbers are still considered very good for a handheld machine. The problem is that most units in this category never publish verified beam quality, and that uncertainty is extremely common in cheaper or older designs. If the real spot was anywhere in the 120 to 150 micron range, the area increases even more, the power density drops even further, and my 20 micron 2 kilowatt advantage becomes 10 to 15 times in real terms. So the fact that it still couldn't punch a 10 millimeter hole into concrete from 32 to 36 inches only reinforces the point. Wattage doesn't matter if the beam isn't concentrated. My 2 kilowatt 20 micron source is operating in a completely different density regime. One more question remains. Which friend of yours has 380 volts, three-phase power in his garage, and not just the voltage, but 100 amps per phase to actually feed a 6 kilowatt handheld laser? Nobody. That's industrial infrastructure. That's factory-class wiring, transformer-class service, and panel space most residential buildings don't even have. So when people online talk casually about running a 6 kilowatt handheld in a garage, they're skipping the part where the building itself can't supply the power. That's why this comparison matters. My 2 kilowatt 20 micron source is running in a real shop on real power with real beam quality, not theoretical numbers that require a substation to back them up.
Let me see. We're gonna shoot it. Okay, let's look at it. Because we got something. Not what we wanted, but we got something. All right. So we did blow a hole into the concrete. And if you see this beautiful radius, because I'm on these settings. See? That's a little bit cheat as well. Anyway, now we're gonna try the same thing from 1 feet. Because the gentleman claims, okay, let's look at it. I tried to aim, I don't know if you can see, I tried to aim to the same hole. So see, it's only a little bit of surface. That was approximately 20 inches. But again, I'm 8.3 times more powerful. Now I'm approximately 30 inches. I know because my table is 30 inches. Okay. So now it's only just burning whatever is on the surface. But once again, I want to point out, see, it's just surface. And it's hot as a motherfucker. So first, we did just as a big hole as the laser itself. I'm gonna show you over here. Look at that. Actually, let's do it over here. Now, you can see it clearly, I guess. See? So we had the exact same hole. Okay, something like this. Once again, about 32 inches. See, it's just the surface. So, and this gun, this unit, I'm telling you, do your mathematics, it's 8 times freaking stronger than the 6 kilowatt unit at 100 microns. So this case is closed. So we like fairy tales. And I don't know, you guys grew up on Münchhausen or Pinocchio? There it is. So I'm gonna remove the clamp, put it over here. And no wire. I'm gonna bring something over here so I can trace better. Yeah, square. That's good enough. So I can trace better. I hope I'm not gonna screw up my square. And let's trowel. I'm a little bit too shallow though. The fans start to kick in on. Okay. Now, see, I should have left everything handy right here. I think that. Now we're gonna. This weld got just as good as my hand movement. Okay. And no wire and no dishing. It actually has a bump. Can I show it to you guys? Once again, I don't know, I hope it's visible. It's not a valley, it's a hillside. Well, not a hillside, but that's another misconception. Alright? Now, let's see the other side. It's not many things visible. And this is 1/4 inch. Okay, now we're gonna go to the next type of my settings are not for 1/4 inch less, but doesn't matter because it's not the purpose. The purpose is something else. So you guys see this? I hope you see. So now we have the infinite sign. Let me go closer a little bit. This bell beat's never gonna be perfect and it's perfectly nice because we should have cleaned the surface just like any other regular welding and we did not do that. Okay. Are we going to see something different? I don't think so. Or maybe. I didn't change any settings but the profile of the weld. Oh, it's a little bit hotty. It's a little bit different. See? So basically, if somehow I could have explained, I can actually. I'm going to bring up my stick. So the very first one had a profile like this. Oh, damn, it's hot. I can't even draw correctly on this. It's so hot now. How about here? So a profile like this. The second one has something like this. Okay. Let me try to show you. So first profile. The second profile is something like this when I touch it. It's maybe visible as well. So you see on the center, it has a peak, and it drops down, exactly like this drawing. Okay. Let's go to the next. We'll go to the next. And I'm controlling it from the pen. I mean the tablet. Now, let me see if it's visible or not. How about if I turn up my light? I'm back. So I turn off all light. I hope it's visible now. The triangles like a hourglass, right? Okay, let's do this again. I have to move this out of my way. The hourglass. You can hook up the wire later on. I just want to go through this. I exactly know already what's going to be the effect, but I want to have you guys see it. If I would be keeping the exact same speed, it would be much better, much more visible. So once again, the similar effect than the number 2. So we have a drop down, but this one is kind of radial, this one is kind of straight. And once again, a big peak. And what else we can see? I don't think anything else is visible because pretty much the same thing. Now when we put wire into the unit and we increase speed, then you will see the major difference. Should we keep going? Okay, what's the other one? Oh, this guy. So the larger circle and the smaller circle. The very first one was just one single circle, now it's a double. One outside, one inside. I don't know, it's visible, I hope it's visible. When we're gonna put wire in there, that's gonna be more interesting, by the way. First of all, the speed is gonna be constant. I'm not 100% constant with my speed. I mean, today, maybe 38 hours in this machine. I still use the IPG most of the time because the IPG already set up for the brass. I already have the settings. I haven't tested it and it's already working, already tested, so I'm just going to use the IPG. It's a very good unit. So what do we have over here? So almost exactly the same profile as the very first one. I don't see any difference, although but what we can see is my inconsistent speed. That's all we see. Perfectly visible when I stalled a little bit, speed it up, move my hand to the left or the right over there and stuff like that. But you know, we are quite large magnification on this camera. Okay, I have a macro lens on it. So that's why I cannot do wide shots. Okay, a little bit closer. And The single triangle is the next. Okay, single triangle. Let's bring this back. There's not gonna be more difference. Okay, let's hit it. Okay. Actually, I've made a much more consistent speed. See how beautiful? I mean, in my opinion, every single one of them is beautiful compared to what you can do with a MIG welder. Even pro MIG welders, they're gonna have problems to get something like this. I'm absolutely not pro TIG welder. I know I can lay the nice beat, but anywhere close to this, forget it. And stick welding, it's worse. TIG welding, I suck at it. If I have to do a little half-inch something with TIG, that's good enough for me. That's gonna look all right. All right. Okay. So that was the small triangle, I mean single triangle. Now we are at Audi. That's what I call it, almost Audi. Let's look at it. It's so hard to see it because it's so small. That's the Audi. So basically 3 circles, okay? And they connect into each other similarly than the Audi circle, only you're missing one more. Okay, then I'm gonna hook up the wire. Can you hear it? It's totally different effect. Now we're gonna have something different. That's the galvo is working. Since we didn't change any other settings, so we could tweak it. If I do that, this video is gonna be 36 hours long. In my opinion, it's going to be long anyway already. So, it's totally visible what's going on over here. And imagine we're gonna add wire very soon, in a minute or so. There I screwed up with my speed again at the very end. 1, 2, 3, 4, and one more is missing, the conventional. We're gonna go conventional. So conventional speed. Let's do this again. My hand is not consistent. Maybe it would be more cost effective if I don't have to hold a square. Okay. So let's see. In theory, it's not much a difference. Once we put wire in, there is going to be a major difference. Oh, my back. A couple of days ago I screwed up my back. So in this one, okay, but we have wire now. We're going to go backwards now. Now I'm not gonna use the square, I'm gonna try to keep it in a straight movement. I'm gonna keep shooting, so change to the next and the next and the next. And then we're gonna, so now I'm on the Audi. I think the speed is too fast for the Audi, but now we are Audi. Also, the Audi doesn't meant for this thin, thick material. Okay? Come on. Now, for upside down triangle, upside down triangle. My wire is staggering. I have to shorten my freaking hose. Or, oh yeah, fuck me. The wire was running at 360. Anyway, we're gonna go to the next, which is the small circle in the middle of the large circle. See? Okay, the next one is gonna be the hourglass. Let me see my cable. Okay, this is the hourglass. Let me try to go between. Over here. I'm not going straight because I started in the wrong direction, so kind of try to bring it into the center. Okay. Now the infinite sign. Infinite sign. I can feel the wire feeling is not perfect. Either I have to put a Teflon liner or make it shorter. It's freaking 14 feet long. Okay, that was the infinite. And single circle. Next one is the single circle. This is single circle. Okay. And regular conventional single axis galvo. All right. Let's brush. Okay. mount this, so we can look at it. See the difference between the bead profile. So when it matters, when you can do this with your system. Let's say you are welding very thin material. You need a little bit wider bead, or you have a large weld gap and you need to fill it, then the figure 8 helps, because it's gonna melt. Okay, let's imagine. Haha. So let's say we have a material set up like this, right? And let's say the weld bead, the gap is too wide. So imagine if you come in like this. So you melt this part, and in the center, basically you point into a smaller, that is when the figure 8 crosses each other, right? And this material just by gravity, if you do 1G, by gravity is gonna melt into that hole, because the figure 8. Okay. Then the Audi, let's go over here. The Audi, it's kind of similar on a different material. Seriously, I didn't really test it yet to find out the exact potential of this. This one is battery welding, or any other welding, but they made it for battery welding. So you drop down, you power lever, use everything, you drop down and you can level the batteries. This is once again larger gap, it helps. Definitely, that's the best for larger gaps. Okay. Any conventional stuff also is useful for battery, depending. You have to drop your speed. Power levels. So, what I'm gonna do, I'm gonna jump to 24 as the speed, and we're gonna do the hourglass. No, it's hot. Okay. So I increase the speed to 24, and we're gonna do the hourglass. Our plate deflected a tiny bit. Maybe we have to do even faster speed. Oh my god, oh my god. Now the pattern starts to emerge, but it's still not there. Have to go even faster. 24, let's go 28. I'm not going all the way. Look at that beauty. There's bumps because of my wire stalls. basically staggering stalls. I'm gonna fix that. I'm not gonna do brake test, I'm just gonna weld this over here. Then I might have to bring it closer. We're gonna repeat it from this side. So we still have the hourglass. I'm gonna drop it. So this is approximately 30 degrees. I'm not gonna try to break it and stuff like that. I'm sure everybody saw the test videos. Now I'm gonna turn on the big lights because now we are in shade. I know it wasn't in the frame correctly, so what the heck is wrong with this? Yeah, finally. Alright, so let me remove the camera, try to zoom in, see the beauty. And there's the other side. From this side, I'm sure I have 50% to the center if I would have cut it. So I get to 50% on this side for sure. On the other side, I don't think so. Maybe 30, maybe less. Over here I kept it in 45. You have to drop it to 30 to get the most out of it. Yeah, also in my videos I'm explaining it. Actually, the board is still over there. We can hop on the board. So this is the 30 effect. It's quarter inch, 3mm scan, and in theory 4mm penetration. Alright? So when you drop it to 30, it's 6.4 millimeters. 635, but quarter inch, then you see you cross the half line. If you are at 45, it's over here. No, it's still not over here. That's a different setup. I don't have a 45 over here, damn it. So if you do it 45, then imagine you're coming on this, so your scan box is something like this, like my pinky, and you're not getting into the half line. You want to get into the half line from each side, and then you have a cross section. Basically, one weldman is going to weld into the other one. That's a perfect weld. This one is a 700 profile. This is a 1500 profile, and the same thing explanation on. It's one of my videos. You guys need to watch it. You should actually. All right. So it's what I think interesting. Okay, I don't have 30,000-40,000 viewers. I have much smaller amount of viewers. Rarely getting any questions and stuff like that. I'm happy to address anything. I also, what I noticed, because I'm watching everybody's laser video, I try to drop in constructive criticism, help the people. Okay. And what I noticed, the couple of bigger name content creators, they're doing what I'm doing and they started to talk while I'm talking, which means they're watching my channel. But it's basically, you should have tell your viewers where it's coming from, you know? You did not come up with this idea. Anyway, that shows how little men you are. Oh, I know. The cleaning. So in my cleaning video, I put down a piece of paper on the ground, right? And started to point my cleaning effect on the paper. And in theory, as soon as I hit the trigger, the paper should have ignited. It did not. That's basic physics. The laser not gonna couple into the thin paper because the thin paper porous and the cleaning power, it's very low. It's high enough to remove the rust and burn it away, but not enough to couple into some materials like the paper, for instance. Now if you're welding, you're using the welding power, it's going to couple right into it. That's a different story. Alright? So the paper ignited because it accumulated so much heat, it basically self-ignited. It did not ignite it from the laser itself. It just reached the ignition temperature and it self-ignited. Why is that? I mean, why I'm saying it, and maybe you're going to say, oh, it's bullshit. No, it's not. I tossed out the paper, but the paper has 0 pinholes. So if the laser penetrates the paper, you're going to have pinholes with no visible pinholes. I'm going to plug in the video over here and over here. No pinholes on the paper. So it's just self-ignited. And maybe from double effect, because the beams crossing out, going out, and changing directions, heating up the concrete, and that heat reflection just accumulates till it reaches the paper ignition point and it self-ignites. That's what it happened. Otherwise, it wouldn't burn the paper, period, in the cleaning more than that distance.
With that, I'll close this video. Thank you for watching. I hope it gave you some real insight into the laser industry and a proper introduction to this 20-micron beam technology. And just to be clear, you're not doing me a favor by watching this. You're doing yourself a favor by learning the actual game field instead of the marketing stories. See you guys at the next one.